Welcome everybody to Quickly Testing Legacy Code. I'm Clare Macrae. I'm from Cambridge in the UK, not Cambridge in the States, and I work at Cambridge Crystallographic Data Centre. There's some pictures later on to tell you what that means. And although I've been at CCDC since, well, more than 30 years, in 1999 I started working in C++ and Qt or Qt, depending on how you wish to pronounce it. So that probably tells you that I have a reasonable amount of experience of working with legacy code. It may not tell you how much I know about legacy code and fixing it, but I do have quite a lot of experience of it. As I go through, there will be pointers to give you a sense of how far I've gone through. So a very quick introduction. Why I'm talking here is just over a year ago, I saw a tweet from one of my heroes in the legacy code area, Llewellyn Falco. He's an agile development coach. And we were already using Google Test Framework at work. I didn't know anything about approval tests, but he asked for C++ help. And I thought, well, not sure if I'm qualified, but I'm going to say yes. So I did. And a year or so of remote pairing, periodically, not continually. This talk is about what I have learned and the fruits of that work. So my goal here is to share techniques for easier testing in challenging scenarios, not just legacy code, although for a lot of us legacy code is a big part of it. It's broader than the particular library I'm going to be talking about, so general testing approaches. But let's talk about legacy code. What do I mean by that? You're probably familiar with this sort of feeling. Legacy looks easy, should be done in half an hour, I reckon. So imagine that might be familiar to a few of you. But what do I mean by that? Here are some common definitions. I think the most well-quoted one is Michael Feather's code without unit tests. I like J.B. Rainsberger, profitable code that we feel afraid to change. But I work in a non-profit organisation, so I really like Kate's as well. Any code that you want to change but are afraid to. And I wrote that slide a while ago, and then rereading it after Kate's keynote, fear, okay, that's interesting. That ties back really nicely. So whichever definition you want, I don't mind. I think they're all good definitions. So here's the feeling, here's the pain. You need to change some code. There are no tests. Therefore, it wasn't designed for testing, because that's a lot of the benefit of writing tests is you make it testable. So you need to refactor it to make it testable. But what if you break it? You can't change it without tests, and you go round and round and round, and I certainly know that feeling. On this talk, I'm focusing on the right-hand side. So if you're in that situation that there are no tests and it wasn't designed for testing, how do you start to break out of that cycle? Got a couple of references at the end for once you've got there, how do you help with the refactoring? But this is the focus of the talk. So I make a couple of assumptions that I want to state up front. And the first is that you understand the value of testing, because that's a whole separate talk. And that is not this talk. And the other thing is that you try and suspend any concerns about the types of tests, because there's lots of stuff around. You should only write unit testing. They need to be really short. They need to just test little units of code. This is about that situation when that's really hard. So, right, here's the situation. Somebody has acquired some existing code, doesn't matter how old it is, and you've got to maintain it, you've got to add a feature, fix a bug. The number one question to ask is, are there any existing tests at all? And if not, stop there. pause the video, whatever, and go and set up some tests of any sort. And the first test is always the hardest, so don't worry if it's hard. Definitely use an existing test framework. Back in the early 2000s, we wrote our own and eventually replaced it with Google Test. Google Test is really popular within the C++ community, very powerful, very flexible. There's also Catch by Phil Nash, who is the organizer of this conference. They're both excellent. I've used both. I would say that Google Test is harder to add to an existing build system, whereas Catch is a single header. But if you're confident with extending your build system, they're both great. Either one is fine. if you're not familiar with writing tests at all, I really like this book, Modern C++ Programming with Test-Driven Development. And I love the subtitle as well, Code Better, Sleep Better. So take the stress out, take the fear out. Interestingly, on revisiting this before this talk, this book has a long chapter about dealing with legacy code, exactly this. But it starts from the premise, and it's really good worked examples. It starts from the premise that you have to modify the code to add tests, and often that is true, but in some ways this talk is a precursor to that, but this is a fantastic book. So, okay, so in a different world, there were some tests already existing for the code that you inherited. So do you just crack on and start modifying the code? The tests pass. Right, first of all, you need to establish how good the tests are, because if the test coverage isn't good enough, you might accidentally break something and carry on blissfully unaware. So the first thing to do is test the tests, but only worry about the tests in the area that you're changing. It can be tempting when you acquire a large amount of code to look after, try and understand everything. That's not a way to happiness, it's not a way to productivity. So try and focus on testing the tests in the first area you need to change. How reliable are they? So I'll talk quickly about a few techniques for that. One that's often referred to is testing the code coverage. So that's saying you've got a body of tests, they're executing a body of code. How much of the body of code do the tests cover? There's a huge word of caution here. You can have the most amazing test coverage, you can be executing all the code, but never actually test any of the results that come out. So I am not saying you have to get to 100% code coverage. I'm not saying you have to do that. I'm saying it's one possible approach to take. What it definitely will tell you is any library code, application code you've got that isn't executed by the tests at all. And that's really, really important information. A couple of techniques for doing that. One I learned from a colleague a long time ago. Put a breakpoint in, lots of breakpoints in the library code. Run it in the debugger. Each time you hit a breakpoint, delete the breakpoint. At the end, all of the remaining breakpoints tell you unexecuted code. So it's an approach without setting up tools. And maybe you learn a bit about the code along the way, see what's called. Another way is to use a code coverage tool. So that's an automated tool that follows the execution of the program and in some way gives you visual feedback as to which lines were executed. Don't worry about the detail of this next slide, just let me talk through it. So this is a tool, it's a free tool for use in Visual Studio called OpenCPP Coverage. And all the lines in green in some complicated code that doesn't matter are lines that were executed by a test. And OpenCPP Coverage says at the bottom, from the implementation, I've got 100% test coverage. If anyone's seen the Gilded Rose Carter exercise by Emily Bache, that's what this is. So, right, 100% coverage, we're done, aren't we? But this line 10 that's marked in red says if something and something else, then do the code in parentheses. And when I throw a different code coverage at this code, a different tool called Bullseye Coverage, which is a commercial tool, the other one was free, Bullseye has an option to show you for each condition whether it was covered with true or false or both or neither. So again, this gives you a sense of what's missing. Maybe, honestly, you don't care. Maybe you look at the numbers and you say, that's corner cases, that's not relevant, I'm not going to spend any time on this now. Or it might say, oh, that's really important, I need to look at that more. And that's the feeling I'm talking about getting. And Bullseye doesn't show you the results in Visual Studio, which initially I thought was quite inconvenient. But that original line 10 here is presented as 10A, 10B, 10C, and it's showing me true-false coverage for each of the conditions. And so Emily Bache, who popularized this coding exercise, the Golden Rose Carter, has a series of 3 videos where she talks about the testing techniques that I'm going to be talking about, but then applies that to this code. Happens to be in a different language, but it's the end result. You get the same learning. And then using this technique to extend the test coverage, and then a really powerful refactoring technique that I haven't heard of. The next technique I want to talk about is mutation testing. And this is really fun. This is where you test your test by sabotaging your code. It's really good. You've got version control, right, so you can undo the sabotaging. So you make small little changes. You think, how might a future developer accidentally break this code? And you do that, and you run your tests. And it's the complete opposite of normal test running. If your tests fail, that's good. You're happy. Your test suite found that mutation, that sabotage. If your tests pass, that's a case, a bit of your logic, a bit of your implementation that wasn't tested. You then have to decide if that matters or not, but that's really valuable information. So you can do it by hand, changing operations, changing magic numbers, that kind of thing, or you can use a tool. For this scenario I'm talking about, personally, I wouldn't bother setting up a tool at this point. I would just use the manual testing, look at the to get a sense of after you've seen the coverage of the code, but that's a personal choice. So you found that there are some tests. In an ideal world, you've done what I've just suggested and you've gone, that's good, the tests are great, I can start refactoring. But just in case that didn't happen, that's what the bulk of the rest of the talk is, approved files. You might be thinking that's really useful, that the approved files are next to the source code, or you might be thinking, oh, that's a bit cluttered. And some of the other implementations of approvals have a way to customize the output location. And as people start using the library more, I'm hoping we'll get some feedback that says, I want to be able to customize the output location. Maybe if someone's watching on video, it might have been done already. Now quickly onto the Google test boilerplate. So this is what you put in a Google main if it's a brand new Google test project. And this is what a brand new Google test, traditional conventional test looks like. So name of test case, and this is often the class that's being tested, and then something about the thing itself, the aspect that's being tested, and then the traditional expect. With Google, you have to say equal to, not equal to, and so on. And then the approvals equivalent is the code in yellow is identical to what I showed you for the catch framework. So once you've got it set up, you don't have to worry about any differences in behavior at all. It's completely hidden what the test framework is. Although it doesn't show it here, there's nothing to stop you putting, in this case, additional Google expect equals or whatever you can mix and match. It's not either or, it's whatever helps you most conveniently test your code. For reference, if you have an existing Google test framework and you want to add approval tests, add the lines in yellow. For reference, if you use a different test framework than Catch or Google Test, it's really easy to add support for a new test framework. This is what's needed. The slides will be available afterwards. Talk to myself or Llewellyn if you want a hand with it. A note on tools, again, I mentioned a few diffing tools and things like that. There's links at the end. Okay, so that's great. Theoretical, trivial example, that's all nice, but come on, how hard, how easy can it really be to add it to existing legacy code? I'm going to show the general principle of adding support to new types in approval tests. So the general principle is that you wrap up all your setup code for your application, your library, whatever, into a convenience function that returns something that you can represent with approvals. It took me quite a while and several times of Llewellyn describing this to me and then me showing him code I'd written in the example I'll show later on before I really understood the power of this. No, I understand that's what you're supposed to do, but our stuff's really hard to set up. I'm going to create the widget and then get the thing and then draw. No, hide all of that. Sure, if you want call this lots of different times, pass some identifier, some value, some customization in, so you can have lots of different instances of do legacy operation, but really try and make it so that your approval tests are two-line things. Do something, get something that tells you about the result, and then verify that result. So in this fictional example, we had some class called legacy thing, and here's do legacy operation with your complicated implementation there. With the verify method that I called, it requires that the thing being verified has an output stream operator, so write to an O stream the thing. Now, maybe your code that you've inherited has that. Maybe you're inventing some new wrapper around existing data and you can add that, or maybe you write a free function. It doesn't matter. There are other overloads that provide different ways of doing it that don't require the output operator. So could you say the question again? Okay, so the question was what kind of operator? So it has to, what approvals looks for is an operator that writes to standard O stream, and that could be used to save to a string, or it could be used to save to a file. But by default, that's what you provide. But I'll go on and say there are other ways of doing it, so I'm happy to talk more afterwards if that didn't make sense. Okay, so that's your implementation. So I'm hoping that if you have in mind a hard-to-test system, you might be able to start to think how to translate that to this framework if you think golden master testing is useful for you. So I'm going to talk a bit now about some of the features of this, some of the benefits. It takes care of file naming for you automatically. It doesn't matter if different developers have got the repos checked out to different locations. It takes care of line endings. Now, this was something I was a bit puzzled about at first, but it's very opinionated about its. There have been so many times where people have checked in code on Windows with Windows line endings, and then a Linux developer comes along, checks it out, line endings differ. It says your text files are equivalent if their content other than line endings are the same. And if you don't like it, you can write your own implementation of the comparison, but by default, you don't have to worry about line endings. It makes it quick to write lots of tests. So I showed you approvals verify, and this is a container equivalent. So this is approval verify all. And so to use this, you can either pass in a function or you can pass in a lambda that says, in order to test at one value from my container, so my container is int, so one value, I'm going to call it v because it's PowerPoint, not because I would call it v in real code. I would call it value in real code. And you're required to, the last parameter is the stream here s that you're writing to. So my lambda says I'm going to send to the stream my value. That's the input, so I'm going to write out the input for convenience of checking the output. Something that says I'm converting that to, and here it's v squared. And remember the new line, because that makes it a lot easier to read the output. And in this overload, you can pass in some description. So if a diffing tool pops up and it says, this is different from that, instead of the developer having to scrutinize the file names, they can look at the first line and say, oh, this was testing squares, okay. 5 squared is obviously not that kind of thing. So that was about a single container of values to test. It goes way beyond that, though, so it has verify all combinations. The comments in here for people to read the slides later, I'm not going to talk to them all, but the principle is you pass in any number of containers of any number of types, and it does a combinatorial, all of the values in one times all of the values in the next. When I say times, I mean do the operation with value 1, value 1, value 1 from the first, and then it loops over one container and then loops over the second and so on. This next slide might make it help. So the Gilded Rose example earlier, Gilded Rose has 3 inputs. Doesn't matter what they are. And so this is brilliant for saying I'm not going to have hundreds of separate test cases. I'm going to have a container for each of the inputs. And if code coverage tells me a value isn't tested, I'll just add it to the container. So here with my hello world and 1, 2, 3, you see 3 times 2, 6 outputs. But you can go up to thousands, hundreds of thousands of outputs. And you see what's lovely is it shows the input and the output. So if you get a difference, it's not just 42 went to 43. You can include in the lambda what the inputs, any meaningful information. So now coming on to the question, which I don't think I repeated earlier, what if the output is not stable? So here's a fictional example. Imagine this is the fuzzy text is some output log file, and it happens to have a date and time in, or maybe it has object addresses, something that isn't stable. So the traditional way of dealing with that, and I think what a lot of refactoring books would tell you, is to introduce a date-time abstraction in your code. So in your production code, what would give the date and time for the logging is the real date and time. In your test example, you pass in something that says it's always the 1st of January 2019 at midday or something like that. Well, that's great if you can do it, but we're in a world where we're not comfortable refactoring code yet. So that's, if you feel bold enough, if you feel confident enough, that's great. Another way is to customize the comparison function to say, if I'm diffing 2 lines and they contain dates, then ignore the date strings, which is a bit better. But in a large output file, that's 2 lots of information that you're comparing. And so what Llewellyn advocates is a different approach, which is to strip the dates from the log file. That's a really, really brilliant idea. So my approval test has written out a log file that says the time is such and such. And before I compare it, my test code reads it back in, just spins through all of the lines, probably with a regular expression or something like that for what a date is, and converts it to some fixed string. You can put whatever text you want in. You can delete it altogether, or you can put some placeholder text in. So now, and then you write that modified file back out, as though that were the file that were written by the test framework. So you haven't had to refactor the code, you haven't had to compare 2 lines, and in your diffing tool, you haven't had to tell your diffing tool, by the way, if you see dates, ignore them, because both the actual and the approved file will have the placeholder text in. When Llewellyn first described this to me, it was in the context of comparing images, and I was getting subtle differences in colours, which I'll talk a bit more about later. And his recommendation was rewrite the image and round the RGB values to some multiplier that's bigger than the difference in the values. And the graphics programmer and me went, oh, I don't like that. I want to see the original images. But it's a really valid idea. And that, for me, that kind of lateral thinking about what's difficult about doing the comparison, let's make that go away rather than making our test framework more complicated to deal with it, is a really powerful approach that I commend to you. So your tests need improving, and it's not yet feasible to write unit tests. So let's talk about golden master, or let's talk about testing legacy code. So a phrase that Llewellyn and others talk about a lot is locking down the behavior, locking down the current behavior of the code. It means capturing and preserving the output. It doesn't matter how you do it, it's having a technique to quickly and efficiently capture that behavior. So you could do that by writing unit tests. You could construct small objects that are quick to set up from the code that you've inherited and you don't know anything about. You could write tests that capture the intended behavior, but you may accidentally preserve some behavior that's not right. So even if you can do this, it's a very time-consuming thing to do, massively time-consuming. But it's a very hard thing to do. So is there a better way? There's an approach that's referred to as golden master testing. Imagine it might be something that's familiar to quite a lot of you already. And the idea behind golden master testing is that you take some input data. I'm glossing over the fact that maybe you don't know the full range of input data to provide to your program yet. Maybe you got some ideas from looking at the test coverage, but you take some input data, you feed it into your existing code, and you save the output. And you call that output the golden master. It's something that you're going to save and refer back to. So that's the setup. That's the first stage of using golden master testing. And now, as you're updating the code, probably the first thing you're going to do is refactor the code to start to make it testable, or to start to give better names and things like that. In the situation where you had not intended to change the behavior of the code, you put the same input in through your modified code, and is the output file the same? If the output file is the same, then yes, your change passed and you're good to go ahead and check it into your version control system. Obviously, the reverse of that is if the test failed, then you go back and you fix the change you made or back it out and try a different approach. So that's the idea behind golden master testing. And I first heard about it at a meetup in London, I'm not sure, 8 or 10 years ago, a long time ago. And I implemented a version at work, which I was quite proud of. But actually, it had problems like it was hard to create new versions, new output if it deliberately changed. People didn't understand how to use it. It was really hard to inspect the differences if it failed. You had to set an environment. Someone added an environment variable to say, if it fails, open it up in a diffing tool. So Golden Master's great, but what matters a lot is how easy it is to use. It's kind of a poor person's integration test or tests. But it really depends on how easy it is. But again, I'm going to say don't worry about it's not a unit test. It doesn't matter at this stage. Be very careful about not overwriting your master by mistake, though. Definitely make sure you check it into version control. So moving on to now quickly testing legacy tests. Legacy code, sorry. So one approach is an approach called approval tests. And I mentioned Llewellyn Falco earlier, asking for help with porting approval tests to C++ and Google Test. And this is a technique that he invented and has popularized and advertised widely. And there were already implementations in a wide range of different languages, but there was a C++ implementation, but not using a commonly used test framework or anything like that, not using at all modern C++. So, but now there is a C++ implementation of the approval tests framework. It's called approvaltest.cpp, and the next chunk of the talk is going to talk about how to apply that to any code, but especially legacy code. But just briefly to give you an introduction, it runs on all the popular desktop platforms. It has been applied to kind of embedded programming and things like that, all kinds of situations that you might think, how can it possibly be applied to? I can't tell you much about that, but if you work in that area, I would definitely say talk to Llewellyn and find out how he's worked with companies to use it in that area. It's on GitHub, the link's at the end. It's header only, it's open source, Apache 2 license. And these days it works with the two frameworks I mentioned before, Catch and Google Test. So if you just want to get started playing with it, an approach that Llewellyn does for his libraries is to have a library.starter project, so you can just quickly download and use that. So you can just download the zip from GitHub. That's really good. If you're using the Catch framework, these next slides talk through, just as a reference so people can refer back to them, how to use this with Catch and a worked example, and then I go on to the reference for Google Test as well. So in your main, you have to have these two lines. Doesn't matter about the detail, it just sets up your main so it knows to listen out for approval tests. This is with Catch. For anyone who hasn't seen Catch tests, you name your test case with test_case in capitals, and you require that the result of one operation, calculation, object is equal to a pre-stated known correct result. And that's how the majority of unit tests work. What approval tests does, and this is in catch, so you've still got the catch header, but you add the approval test header, is you call approvals verify, or one of a number of similar methods. And here, as a totally artificial example for test purposes, I'm passing in a fixed string. Hopefully it's clear that that's just for demo purposes and you'd have real code there in the real world. So it's a 3-line string. And you might be thinking, well, this is weird. How can a test case not tell us anything about what the expected answer is? How does that work? That's really strange. The first time you run this test, it fails. The approvals test framework says name of your source file. There was an exception, failed approval, approval file not found. And then it tells me this happens to be where the source file is. So the source file was in demo approvals and catch 2. It was test02.cpp. That was the name of my test, and then approved.txt. Right, okay, what do I do with that information? Well, it very helpfully pops up a graphical differencing tool. And this is part of its convenience and part of its power. So I haven't told it anything about what graphical differencing tools I've got installed on my system, but it's got a list on different platforms, and it searched through until it found one that I had installed. So a word about vocabulary, because that's quite important in understanding this. You might be familiar, if you've used existing test frameworks, that you've got something called expected. That was my 2 in my 1 + 1 = 2, and then the actual result would be the result of the calculation when the test ran. And approvals use the vocabulary, your approved file, and then your received file. And I think Llewellyn kind of wishes that he might have chosen actual and expected. And I want to say a word about consistency at this point, because you might think there's a few names that I use here that they aren't the best names, but I mentioned all of the other language implementations of this, and it's absolutely fantastic that there's consistent vocabulary across all the different languages. So if you work in multiple languages or you want to add a new feature, you can say, how was it done in this other language, and make it consistent. And I found that really valuable. So on the right, we have our approved file, which doesn't exist. It's an empty file. And on the left, we have our received file, and it's the 3 lines that was in our source code. And our axis merge, which is this differencing tool, is saying there's one change, 3 lines on the left, 1 on the right. So whatever differencing tool you would use, if you like the output at this point, then you would click on whatever there is in the user interface that says copy from left to right. And now you see I've got these changed lines on the right. The files are identical, and I can then click on save, and then I can close the file. So now that approved file exists on disk with those 3 lines, and then when I rerun the test, as long as I haven't changed the implementation of the code or changed the test, approval says, okay, received matches, approved, test passed. So then we commit the test, and at the same time we commit the new approved file or files, and we keep running away to our heart's content. Future runs, it doesn't show up the differencing tool. It's your convenience, your time matters. It only shows the diffing tool if the approved is different or is missing, or the 2 files differ. And it turns out to be fantastically convenient. It's a brilliant form of golden master testing. It does require, in the default implementations that I've shown you, that the objects that you're writing out are stringifiable. They need to be able to be represented as text. That's not true for all tests, but if at all possible, if you can have a meaningful string representation of the data you're testing, you'll get going with this really quickly. So that's how we capture the current behavior. That's how we lock down the behavior of our current code. Hi.
What about if your output is non-deterministic?
I'm really glad you asked that, because I've got a slide on that a little bit later. Thank you. So at the risk, I think it's, again, I'm going to stress, it's not intended to replace unit tests. You can use it as unit tests for small stuff if you want, and but it's a way to get testing hard code. So the projector got knocked earlier, unfortunately, so it's a little bit fuzzy. But what's highlighted in blue is the names of some source files in a fictional test directory, and then the other files are. In the interest of time, I'm going to go very quickly over this example code. There's an abstraction for how approvals writes out files. So you can overwrite that. You can re-implement that to say, after the file is written out, strip out data that's variable. You might be thinking, but I've got a build server, continuous integration builds. I don't want differencing tools popping up. Fine, it uses Quiet Reporter, which silently doesn't do anything if there's a difference in file content. Importantly, the test will still fail, but it won't do anything to help people make it then pass. That's not the job of a build server. And these reporters are really, really fundamental to the flexibility and the power of this. It took me a long time to really understand this. So if you do adopt approvals, then I definitely encourage you to look through the supplied reporters. So an example would be, okay, I'm happy with my golden master. Now I'm going to change the implementation. I've got thousands of golden master files. I don't want to have to go through a diffing tool one by one. So pass in a reporter that says, copy the received file to the output file or move it, and then I'll spin through in my version control system and review the differences there. And if I'm happy, I can just go ahead and commit. And just remember to change the source code back to not check in the automatically overwrite the approved file or your tests will wrongly pass. Those kind of ideas are really powerful. You'll quickly find that you want to localize how the reporter is created. So if it's a CI build, use a Quiet Reporter. If it's a developer build, use a different one, and so on. So you'll quickly find you want to create a helper function for that. Now, on again to another general approach that I learned on working on this. So an approach called convention over configuration. So I talked about the Golden Master implementation that I set up at work, and if you wanted to diff it, you had to set some magic environment variable. Whereas the philosophy of approval tests is do whatever it takes to make it easy to use out of the box, but provide customization so if people want to change the behavior, they can do. And I think that goes beyond testing. That's actually a really powerful philosophy to have for any library that you write, possibly even applications to write as well. So I'm very quickly going to spin through an example. So I work in the world of chemistry, and before Christmas, so this is a screenshot from an application that we have that displays crystal structures. And ever since 2001, when this program was launched, it represents atoms as spheres of varying sizes and bonds as cylinders or sticks. But there's a whole load of chemists who want to see polyhedra for some of their atoms. And so I had to kind of engineer in to, admittedly, there was already a good abstraction for it, for some atoms to draw them in a different shape. I was going to talk about crystals and molecules and color coding and 3D molecules and lots of molecules, but in the interest of time, that's given you a glimpse of what it's all about. CCDC, where I work, curates and releases a database of nearly 1 million experimental crystal structures. You can go to our website, search for a medicine, download its coordinates, read it into this free program Mercury, save it as a 3D print file, that kind of thing. There's lots of powerful stuff there. So I wanted to see if I could use approval tests on images. I could actually, it's true to say, I could have represented an image as a text file by writing out XY RGBA equals through I don't know how many hundreds and thousands or millions of pixels, but that wouldn't be very convenient to compare at the end. I could have written out the drawing instructions, move, draw, change color. That wouldn't have been very convenient. So I wanted to verify the image. So reminding you of the original pattern I talked about before, I didn't want to verify a Qt widget. What does that mean? I wanted to verify a picture of the widget. So in Qt or Qt terms, the image class is QImage. So hidden behind this load entry, which of course I'm not going to show you because it's totally specific code to my scenario, is create a widget, get the database entry, who's called 6-character identifier, set the display style to the new style, the polyhedra, and draw it, create an image, return the image. And then when I first implemented it, actually the text diffing amazingly worked out of the box in approval tests because it reads each file and compares each byte, and they happen to be the same in the environment I was running it in. So I didn't need a custom image, any custom image code initially, but at some point I started needing it. So this is the real lowest level of approvals. So any route through that I've shown you comes down to this function. And as I go through, I'll talk about these different interface classes. So reporter I've talked about already. Approval writer I'll talk about. Actually, approval namer I won't really, but you'll see some example code of how to create one of those. So first of all, for my verify QImage, so my QImage version of using the interface I just showed you. So the pattern is you pass in the thing that you want to verify, and you provide a default reporter, but you allow people to provide their own reporter if they want. And then you call approval. You use approval test namer. So I think it's very unusual to customize approval test namer. You create a writer object, and then you call file approver verify. So that's that lowest level method that I just talked about. So here's the approval writer interface. Get file extension helps the approval test framework to know how to name the file that it's going to write out, which helps the diffing tool know what kind of file to show. Write is the all-important method that actually says the object that's being tested, represent it on disk. And then cleanup received, I realized actually in writing this talk that's a bit ambiguous. It doesn't refer to the cleanup my log file type thing that we were talking about earlier. You would build that into the write method. It refers to if my test passed, delete the received file. I only want to leave the approved file on disk if the test passed. So if I'm writing a QImage, I have a constructor that takes an image, saves it as a data member, because approvals isn't going to ask me to write it out till later on when it's ready in the framework. So it holds on to it. That underscore happens to be our naming convention at work for data members. And then just to show you the write implementation. So I've got my data member, my QImage, and it happens that the QImage class provides a save method to save an image to disk, and based on the file name extension it chooses the format to write. And anyone who's written Qt or Qt code will know that they have their own string class, and so you have to convert from one to the other, and that's just life if you live in the Qt world. Thank you very much. So I got really useful feedback from this. I at one point made my test framework more efficient by creating, instead of one widget, one structure, throw that away, one widget, one structure, I decided to reuse the widget. And our crystal structure drawing code is not supposed to care if you've already displayed a structure already, but these little red dots there were differences in the end result. And there's no way I would have noticed that in the real world. So that was really useful. Everything I've talked about so far I was doing via remote desktop, logging in from home over the Christmas break, thinking about writing my talk here and using this to help write my talk. And then I got into work and reran my tests, and they all failed. All of them, every single one failed. I don't have a slide for that. And what I learned is that some aspect of the code I was using when I was remote desktoping in was saving 24-bit images. And when I was running it locally, it was saving 32-bit images. And byte-for-byte comparison, that was different. Ah, okay, that's interesting. That was a difference I chose to ignore, but I changed the code. Basically, at that point, I said, okay, I'm only going to run it internally, and I'll save 32-bit images. Time moves on, and then I started getting flickering random test failures. Okay, that's a nightmare. How do I find out? And at this point, I was using Araxis Merge as the differencing tool, and I did lots of experimenting, and there was no way it would show me any differences. Nothing that was visible at all. And I'd heard good things about Beyond Compare, so I tried that out. And it showed me you've got 4 pixels that are different between your approved and received. And so just I'm going to flash through a few screens that zoom in. Still can't see any difference, still can't see any difference. Maybe you're starting to see some red there. Okay, so this was 2000 magnification, and these are my 4 pixel differences. And down the left-hand side is a panel that you won't be able to read, so the next screen zooms in and shows that little panel. So I hover over one of the differences, red 42, red 43. So you have to decide whether that's important. I decided no human was going to be able to tell the difference. So how do I deal with that? I wasn't comfortable with rewriting the image files and rounding the RGB values. I wanted to see the actual files that were written out. So we introduced an abstraction, approval comparator, and that takes the received path and the approved path and has a method that says, are they equivalent? And you have to decide. By default, with strings, it says they're equivalent, except even if line endings are different. I chose to say for images, so QImage approval comparator, have a function which says if there's no more than a unit of 1 out of 255 different between any of RG and B, and the pairs of pixels of an image of the same size, that's good to go. Okay, and then another reference slide. In terms of developer convenience, when I first implemented this, then every verify method had to pass in a comparator. We ended up with something much nicer, which is in your main, you register for a given file extension an overriding comparator to use, which is just lovely. It's really nice. So as you're looking at differences, you have to decide if the differences matter. And I think a lot of us might have experienced that legacy code can be quite brittle. So if somehow you have to work out for your scenario whether it matters or not. Maybe you have to find a domain expert, maybe you can work it out, maybe you log a bug and come back to it. But at least by having approvals, you can get that feedback. If you don't have a way to see the differences, you can't even begin to decide. And for me, that's the power of this. So looking back, it was useful. I learned stuff about our own code, our visualization code. I learned a lot about approvals and how to apply it, even though I'd been working on it. It improved a bit. I was able to write some outline documentation for approvals. And at the end of all of this, that image story, I'm going to delete those tests. I found that those images weren't even stable between my one machine, between remote desktop and local development. But the experimenting I was able to do and the ideas it gave me for further testing and the unit test cases that I was able to write because of problem cases I found by quickly being able to spin through massive numbers of structures was so valuable. Thank you. A quick reminder of the customization points. Very quickly going to spin through some useful resources. Beyond Compare, I love Araxis Merge, it's brilliant for text. Beyond Compare is fantastic for images as well. Really recommend Bullseye coverage if you can get someone to pay for it. We happen to have a license at work, so. This is a lovely video on Pluralsight by our very own Kate Gregory. Lots of really, really good advice on dealing with legacy code and updating it safely. A lot of you may know Jonathan Bocara. And he published on the 1st of February the Legacy Programmer's Toolbox. And I'm working through that. I haven't read all of it, but everything I've seen so far, it's great. So really recommended. If you get to the point that you're happy with the tests and now you're ready to start refactoring, and you go, okay, I don't understand this code. How can I refactor if I don't understand the code? Where do I start? I can't read through all of this code. This is the video for you. The URL is in the text at the bottom. Sorry, it's small. By Llewellyn Falco and Woody Zool. And it's a brilliant cycle of every 2 minutes, make a small change. If it works, commit, commit, commit. Oh, look, now I'm starting to understand the code. Oh, we can give that a name now. Okay, we don't need that anymore. Now we start to understand what it does. The last of the reference slides. Adam Thornhill is actually an academic researcher who has been a developer for a long time as well. And a few years ago, he published the fantastically named Your Code at the Crime Scene. So how to do forensic analysis of the history of your code based on version control. And more recently, he wrote a newer version of it, Software Design X-Rays, which I gave him a lot of feedback, did a lot of reviewing as he worked on the book, because I knew it was going to be really powerful. So I really recommend that. He's doing a training course in London in the next few months as well, which I learned today I'm going to go on. So I'm sure that's going to be really useful and maybe see a few of you there. So quickly now onto the summary. Just about 3 slides here. So the first thing to say about adopting legacy code is however scary it is to do it, you can do it. There are resources out there. There are people who've been working on it a long time. They're responsive to questions. They're happy to help. They're happy to share expertise. And I include myself in that list now as well. So quick steps, evaluate your current tests. Quickly improve the coverage with Golden Master. Approval tests is one way to do that. And it's really quick even for non-text types. If you're using approval tests, remember verify, verify all, and verify all combinations. And remember that pattern of do thing, get representation, verify representation. And remember, if you've got log file challenges and things like that, you can always adjust the output files after they've been created. I guess that's not specific to approval tests, it's just that approval tests makes it really easy. So here's, I think, the pictorial representation of what approval tests is all about. You create your golden master, and then actually you have this loop of refactor code, add unit tests, refactor code, add unit tests. And at some point, you're happy enough and you can start adding new features, fixing bugs, and you then have to decide whether the approval tests are worth keeping or not, or keep some of them or not, but don't feel wedded to them. What matters is the knowledge that you get out and the capability that you get out. So thank you very much indeed. There's just, I'll leave this slide up, and later on from Clare Macrae UK, I'll tweet this information so you can get to it. But in the remaining 5 minutes, I'm happy to take any questions. Gareth, hi.
Hi. Do you already have all three sort of custom comparators? Imagine stuff like XML comparison or JSON comparison, where the order of elements doesn't matter. Could be something that's quite useful out of the box.
So the question was, are there comparators for things like XML files and other things like that, which are standard things? For C++, the answer is no, there's not yet. But I think the .NET one in particular, implementation of approval tests, has a really rich framework there, and that shows how to implement that effectively in other languages. So rather than implementing those features right now, we're waiting to see if people will actually use them and then look at implementing them. So please do give us feedback if you do try it out. But if it's not there and you want to use it, I definitely recommend looking at the approvals GitHub account at the other language implementations, and you'll get lots of good ideas, like a really nice way of stripping out the dates and times from logs. So kind of an adapter or modifier or something. You can write lots of different implementations of that. Any more questions? Hello.
Is it possible to kind of combine to generate reports using Google test or catch test results as a kind of logging or looking at the preconditions? I am testing from remote, log it, so you know like exactly what the preconditions post-practical test, or what else you have been testing.
So, do you mean to include in the output information about the situation?
As a measure of interest to see what other tests have been run and what is the result of them.
Yes, so I, if I understand correctly, what I would do with that is in my golden master file, I would put information about the scenario where it was run. And you'd want to make sure that you compared files that were run on the same environment. But that would get quite complicated.
It didn't need to be in the same file, but at least kind of have kind of logging, so you're able to check afterwards if something is going red.
Right. Okay. Okay. So yes, if you were running it in a build system, the build system would tell you about the environment it was running in. If not, you'd have to provide some mechanism yourself. This is all approvals is caring about is this is my input. Save it to disk and make it easy to update it. So you either put more information into the output files, say what the context of running, or use some other mechanism to do that. That wouldn't be an approval specific thing. Hi.
Hi. Would you ever consider changing the legacy code to like add approval specific logging to say I reached this point of the legacy code and have that be compiled out when you're running in production?
I not. The short answer is I don't know. I tried a few years ago writing end-to-end tests for some really complicated GUI code when I didn't know about this approach. It took me a month to get into a really powerful, really valuable bit of scientific functionality, something that would run repeatedly. And it was then that I discovered the Llewellyn-Falco-Woodizor video about refactoring. And I wished afterwards that I'd known about this approach for testing. So I guess probably what I'd say is if you're dealing with getting legacy code under test, take any reasonable measure that you feel comfortable with that it's going to get it testable as soon as possible, and keep a list of things that you want to revert later on and if that means making something public or protected when it was private, and that's what you need to start getting that feeling of confidence, take away the fear of changing it, I would say knock yourself out. You know the scenario. Got time for one more question at the back. Yes. So it's really important that the output that's tested can be committed into a version control system so that as other people run the code, as the build system runs the code. So I can't think of a kind of thing that wouldn't ultimately be written by file because that's core to the mechanism. But you can take all sorts of things that aren't file based, like that Q image, and so long as you can find a representation to write it to disk in a reproducible form, then I think that would. So, apologies. So the question was, what do you do if it's not a file-based thing? And I think my answer is, as far as I can see, using approvals, ultimately it has to be version controllable. It has to be a file-based thing. To copy and paste the output into a version control system into the source code would take away a lot of the convenience. So then it's finding a file representation that's quick enough to compare so that if a developer or a build system finds a difference, it's easy to inspect what the difference is. Right. Mm. Ah, okay. So the question. Yes. Okay, so if the files that you're writing are so large that you need to compress them when saving them, that's fine. You would use one of the customization points in approvals to having written out the compressed file probably in the comparison point register. If I'm comparing a zip, then this is the the object, the class, object of a class that I want to use to do the testing. So that would fit very, very nicely. That's a great example I hadn't thought of. So I think in the interest of time, I need to stop there. I'm staying around this evening as well, so happy to answer any more questions and heading off tomorrow morning. So thank you everybody for coming and for great questions.